Welcome back, everybody. Section 10.7, and today we're looking at surface area of a sphere. Living on Earth, we use area formulas for rectangles, triangles, and circles to find the areas of most small land regions. But to find Earth's surface area, we need a formula for the surface area of a sphere. We will use what we know about the volume of a sphere to arrive at the formula for the surface area of a sphere. Whoa, who's that guy? So what if we wanted to find the surface area of this bug's eyes? While they're not perfectly spherical, they certainly are round. What's more like it? What about a soccer ball? Spherical in shape. What is its surface area? Well, look at the parts of the soccer ball. It's broken down into regular hexagons and pentagons. What if we found the area of each of those hexagons and pentagons and then added them all up? Maybe that would work. Visualize a sphere's surface covered by tiny shapes that are nearly flat, almost like that soccer ball. So the surface area, capital S, of the sphere is the sum of the areas of all the near polygons. Each of the near polygons is a base for a pyramid, and the radius r of the sphere is the height of the pyramid. So the volume, capital V, of the sphere is the sum of the volumes of all the pyramids. Let's look at the diagram. Now, there's a sphere, and we're taking a tiny little piece of that sphere from right there, and we are going to pull it out and enlarge it. And that tiny little piece ends up being a regular pentagon. All right? Now, that regular pentagon is the base of a much larger pyramid whose vertex is back at the center of the sphere and whose height is the radius of the sphere. Now, if we calculate the volume of every one of these pyramids and add them together, we would have the volume of the sphere. This could lead us to the surface area of a sphere. Let's move on. Okay, so there's our sphere with our diagram. We have the pentagonal base of the pyramid. We're going to call that base B sub 1. Now, step 1. Divide the surface of the sphere into 1,000 near polygons with areas B sub 1, B sub 2, B sub 3, and so on, all the way through B sub 1,000. The surface area of that sphere would equal the sum of all of these little surface areas. So we come up with the equation S equals B sub 1 plus B sub 2 plus B sub 3 plus ... all 1,000 near polygons. Since you're taking notes at home, I would definitely write down each step and the formula as we build it. Now, let's go on to step 2. The volume of the pyramid with base B sub 1 is 1/3 B sub 1 times R. Now remember that the volume of a pyramid would be the area of the base, which is our B sub 1, times the height, which, remember, the height of this pyramid is the radius of the sphere because the vertex goes back to the center of the sphere. So we come up with the area of the pyramid to be 1/3 B sub 1 times R. So the total volume of the sphere, V, is the sum of the volumes of the 1,000 pyramids. So when we write this out in an equation, we get the volume equals 1/3 times B sub 1 times R plus 1/3 times B sub 2 times R plus 1/3 times B sub 3 times R, and so on until we have the volume of all 1,000 pyramids. So what do we do with this volume formula? Well, step 3 says to factor the common expression. If you look at each term in this formula, that would be 1, that would be another one, and we would have 1,000 of these terms, and they all have the fraction 1/3 and r, the height of the pyramid, or the radius of the sphere. So let's factor those out. And when we do so, we get the volume formula that you see here. 1/3 times r times the sum of the areas of the bases of all the pyramids. Now remember, back at the beginning, the sum of all the areas of the bases was the surface area of the sphere. So in step 4, we're going to substitute capital S for the sum of all the areas of the bases. And we're going to substitute the formula for the volume of a sphere, which is 4/3 pi r cubed. So the equation from step 3 now transforms into the equation down here at the bottom. 4/3 pi r cubed equals 1/3 times r times capital S. Now finally, in step 5, we're ready to apply some algebra to solve for the surface area. The first thing I'm going to do is I'm going to multiply by 3 on both sides of this equation to get rid of my denominators. That leaves me with a new equation, 4 pi r cubed equals r times s. Now the only thing left to do to solve for s is to divide both sides by r. And now we end up with the formula for surface area. 4 pi r squared. So we finally come to the conclusion that the surface area of a sphere is equal to 4 times pi times the radius squared.